Employees rely on AI tools to summarize meetings, write code, and draft contracts. But every time they paste an unredacted document into a generative AI prompt, they drag those proprietary details straight out of your secure environment and onto a third-party server. Traditional firewalls and data loss prevention software watch your network boundaries for unauthorized downloads or external drives. They cannot see what an employee voluntarily types into a browser tab at the keyboard level. The boundary of enterprise security has moved. It is no longer the physical network edge, it is the prompt itself. We call this the semantic perimeter. When patient health histories, customer financial profiles, and private source code are fed into external language models, it triggers immediate violations of SOC 2, HIPAA, and GDPR data processing mandates. Hitting send on a raw prompt bypasses your existing compliance controls. It surrenders your intellectual property to the training weights of commercial AI models that you do not control. Many companies attempt to solve this with cloud-based scrubbers. These tools act as a proxy, receiving your text and inspecting it on their own servers before passing it along. This still requires you to hand your raw data to a middleman. Transmitting raw text across the internet to be cleaned elsewhere creates an unnecessary attack surface. It duplicates sensitive records on external infrastructure, which contradicts the principle of data minimization. Zero-Trust Data Sanitization, or ZTDS, addresses this risk by changing where the cleaning actually happens. In a zero-trust model, the text must be sanitized locally. Sensitive identifiers are detected and neutralized directly in the browser's memory, before a single packet of information leaves the user's machine. Genuine privacy in the AI era requires an architecture where raw data never transmits. If the information never leaves the local device, a server-side breach becomes impossible. PrivacyScrubber 1.4.4 executes this zero-trust model. On the Security and Privacy Controls dashboard, the browser sandbox toggle ensures processing stays within the local extension. The workflow is frictionless. An employee highlights sensitive text right in their browser and clicks the neon blue shield. Instantly, the local JavaScript engine scans the text. It detects names, email addresses, and phone numbers, mapping them to structured placeholders within the device's volatile RAM. The chat interface shows the result. The original raw data is stripped out and replaced by these cyan, red, and purple tokens before the prompt ever reaches the AI. The language model receives these tokens instead of your actual data. It can still perform a perfect summary or analysis of the contract because the structural context remains intact. When the AI responds, its output will still contain those generic tokens. To make the response useful, the user needs their original data back in the text. This in-memory session map builds a transient dictionary mapping tokens back to original values stored inside volatile RAM. When the AI returns its response, reverse detokenization triggers. The map swaps tokens back to the original text locally, creating a human-readable response. This map exists only in the browser's temporary memory. The moment the employee closes that browser tab, the map is destroyed entirely. This leaves no trace of the original data on the local machine or the external server. This local translation process provides the full utility of generative AI while isolating sensitive data within the local browser memory. Security teams shouldn't have to rely on a privacy policy to trust a software provider. Enterprise privacy requires a definitive, user-executable proof. You can verify our zero-trust claims through an airplane mode audit. Disable your internet connection and execute a data scrub on a document. If you monitor the Network tab in Chrome Developer Tools during this test, you will see 0 outbound packets. The sanitization happens instantly, even without an active connection. This distinguishes the ZTDS engine from competitor tools that fundamentally fail to operate if the internet goes down. The airplane mode verified status provides a technical control that IT can audit directly in the network log to confirm that no data is leaving the machine. Because the raw data never leaves the user's control, this architecture satisfies SOC 2 data minimization requirements and fulfills the HIPAA safe harbor method for de-identification. This design simplifies IT vendor risk assessments. Since no third-party data processing occurs on our servers, the typical multi-month review process can be completed in days. Deployment is straightforward for enterprise teams. Administrators can push the extension silently via Chrome managed policies using a single master license key. This navy and neon blue shield integrates into the daily workflow, allowing employees to use AI without compromising the company's internal data. Secure the semantic perimeter before your next prompt reaches an AI model. You can deploy PrivacyScrubber Pro for your team or start free on the Chrome Web Store.